Hello friends, welcome back to my channel. So in this video we will see some examples on big Endian and little Endian representation of some multi-byte data. In our last video we have seen the basic concept of big as well as little Endian representations. So we'll take up one example. Say we have taken one integer 14342. This is my integer in decimal. It is given, right? So this decimal integer is given to us and we are supposed to store it in a big Endian machine as well as in a little Endian machines, right? And our assumption is that our integer takes 4 bytes. So first what we have to do is, this is one integer number, right? So we cannot directly store it in the form of bytes. It is an integer. So what we will do, this integer we will convert into binary first. This is a positive number. So in case of 2's complement number representation, for a positive number, you simply need to write the binary of that number, right? So see here, the binary of the number will be this one. You can use calculator to find the binary of it, right? So this is the binary of it, or you can go for division for by 2. Any way you can find out the binary of this number. So this binary of this number is actually this one only. Now see, the point is the number is a positive number because sign bit is 0. This MSB is 0 means sign bit is 0. Then now see, this number length is nothing but 4 plus 4 plus 4 is 12, 12, 13, 14, 15 bits only. But I need to represent it using 32 bits. So whenever a shorter number need to be made as a 32 bits long, then what we have to do, whatever is the MSB, that is the sign bit of the number, that will be copied into all other higher order bits to make it of the required length. Here my required length is 32 bit. So all the remaining bits on the higher side will be made to 0000, right? Understood? So 14342 total in binary in 32 bits is this one. Now what I will do, I can store these binary these bytes in the memory from a given address, right? That I can also do. Or see, the easier way, where I am copying this 00000110, I may end up doing some mistake. So what we will do, we'll group these binary bits into group of 4 bits, and each binary 4 bits will come transform it into hexadecimal form. So 0110. See, hope you know how to convert a binary into a hexadecimal. So 0110. 4 binary bits are grouped together to form a hexadecimal digit. So here 0110. From this end I have started 0110. This is what? 2 plus 4. So it is 6. Or you can use the calculator, or you can do it directly the convergence. So it is 6. This part is 0. So basically what I am getting here, it is 0, it is 6, it is what? 8, it is 3, and all others are your 0. Now see how we are storing. The machine is byte addressable, right? Our machines are byte addressable. So one byte as a whole we need to store in the memory. So 06 will store as a whole. This 38 will store as a whole, 00, and this 00 will store. Now we need to go for little Endian and big Endian representation. Say in my memory, my addresses starts from your, so first I have converted it into hexadecimal, done. Now we need to store it. Say my address starts from 100. So in case of little Endian, first LSB will be stored. So it will be 06, right? Again, do not directly write this byte in your lowest address. So 06. Next will be 38. Next is 0000. This is little Endian representation. If I am asked to do the big Endian representation, then what I will do? I will uh, reverse the order of my bytes. So first what I will store? First I have to store 0000, then 38, then 06. So in case of big Endian, your MSB will be stored first. MSB here happens to be 00. So 00003806. So this is how very beautifully we have stored one integer number in your big Endian as well as little Endian machines. So this part is clear. Now I'll take up another example where I am taking a negative number. It is an integer because integers are my sign numbers. This time I'm taking a negative number, and I am supposed to store it in your big as well as little endian formats. So first convert this number into, take the number into your binary form. See, we know our numbers are represented in your 2's complement form. So first what I will do, I will write the binary for 14342, right? I will write. This is positive 14342 using 32 bits because I am going to store a integer. If it is given that integers are 16 bit, you can go for 16 bits also. But here my assumption is my integer is 32 bits long. Then what I need to do, this is positive 14342. Next I need to convert it into negative. So what I am supposed to do, I need to take the 2's complement of my binary combination. So when I will take the 2's complement of this particular one, I will get this. 2's complement, you remember, very easily we can take only 0, 1 I will directly write. After that all other bits I will flip. So it will be 0, 1, then all 1, 1, 1. Like this I will flip the remaining bits. So I come up at this answer. This is negative 14342. Now see, we can store it as a byte in case as a binary bytes in memory, but it will be easier if we convert them into hexadecimal form. Then chances of error will be less. So 1010 is nothing but 10. 10 in your hexadecimal is what? A. Then all 1 is what? 15. 15 is represented by F. Like that, this is 7. This is your 12. 12 is C. Then all 1 will be FF. So ultimately, this minus 14342 is nothing but in hexadecimal this one. What is this H is doing here? I have written H, or you can write like this 0x then the number. I have not written this. I have suffixed this H. H is not part of your number. It is indicating it is a hexadecimal number. Done. Then next we need to store it in your big Endian and little Endian. So now we can do it easily. If it is little Endian, first FA, then C7, FF will store. This is little Endian, correct? If it is big Endian, we'll start from this end. So first FF, C7, FA. Hope this part is clear. In fact, this is very easy. Next, I will do one more example. So, in this example, I have taken a positive integer only. You can take negative also, but I am going to store it as a long integer. So, what will be the length of long integer? If my integer is taken to be 32 bit, long integer will be of 64 bit, right? So, that is the only difference. So, see, first we'll convert this number into 64 bits. So, mostly all these zeros are coming. This part is our actual binary combination. Now see, do I need to take 2's complement? No, because it is a positive quantity. Simply what I will do, I have already grouped them as 4 bits. I'll write their corresponding hexadecimal digits. So it was 3, this is 8, this is 0, this is 6. All others are 0, 0. So ultimately we have got in 64 bits, this is as a hexadecimal number. Done. Now we need to store it in memory in little as well as big endian. So little endian, first least significant byte. So 06, then 38, then all 00s. So this is how we have stored. And in case of this one, what is that? Big endian, where from I'll start? I'll start from this end. So first I will store 00 at this address, 00, 00, 00, 00, then so on. Like at the end, 38 and 06 will come, right? So this is how we can represent one multi-byte information, one multi-byte operand in memory using big endian and little endian concept or format. See, which format to use depends on which machines I am using. So one particular machine follows one particular format. These are two ways of storing your multi-byte information. So this is all about big endian in little endian. Next, we will do one get numerical on this concept in my next video. Thank you. And if you are getting from my explanations, then please like my videos and subscribe to my channel. Thank you.